Hello, welcome. Let's try to solve Leetcode problem 878, Nth magical number. A positive integer is magical if it is divisible by either a or b. So for example, we can try to use a number maybe 6. Yeah. So this number 6 is magical if it is divisible by, so this 6 is divisible by this a2 and b3. Given the three integers n, a, b, return the nth magical number. Since the answers may be very large, so we're gonna return a modular 10 to the power of 9 plus 7. Yeah, I think it's really easy to understand. So for example, we have a with 2 and b with 3. Yeah. So we're gonna just check the multiples of a or b. So we have 2, 3, 4, 5 is not okay, and 6, 7 not okay, 8, and 9. So we have this kind of sequence, and we're gonna return the nth magical number. So the nth number, it means the first number, so it is 2. So this is why we're gonna return 2. If n equal to 4, so this is 1, 2, 3, 4, so we're gonna return a 6. So definitely we cannot use the brute force. I mean, we cannot try to find all those numbers and then we're gonna try the nth magical number. Yeah, because this n gonna be a really big number, so if the time complexity is 10 to the power of 9, definitely it is not working. And a and b should be less than or equal to 4 times 10 to the power of 4. Yeah, even though a and b is a small number, but this n is a really big number. Yeah, if we cannot use brute force, definitely this problem, if we want to solve it, maybe we're gonna think about the binary search. The binary search idea is that we're gonna just guess a number. So for example, this is our range, and in this range we have a number. Yeah, because our number is starting from 2, because a and b at least gonna be 2, so the left side gonna be 2, but the right side gonna be a really big number, as a and b 4 times 10 to the power of 4, and n is 10 to the power of 9. Yeah, so this means if n equals to 10 to the power of 9, so the nth number gonna be this number, 4 times 10 to the power of 4 times 10 to the power of 9. It's gonna be a really big number. And maybe let's just set it to be 10 to the power of 14. I think it is okay. Or we can just choose the maximum of a and b times this times 10 to the power of 9. It is also okay. Or we can just use maximum of a and b times n. It is both okay. Yeah, it always depended on us. But I think the maximum number gonna be 10 to the power of 14. Now, what we're gonna do, we just need to use a binary search to find the number, to guess the number. For example, if we guess the number, for example, let's just guess this number 2. Let's just check if it is possible. Let's first guess number 3, maybe. Yeah, so if we guess a number 3, so we have 2 and 3. Yeah, it meets the condition because we need to find one number, because it is the first number, but we have 2 numbers, it means it is okay. Now we're gonna guess a smaller number, maybe 1. Yeah, but for our case, we will not have this number 1, but it's just for example. If for number 1, it is 0, there's no numbers, if it is not possible. Maybe we're gonna try to guess number 2. If we try to guess 2, so how many numbers? There's gonna be only one number, only 2, because 3 is not divisible by 2, only 2. Yeah. So it means only one number, and n equals to 1, and it is exactly what we need. So this is the binary search to guess the numbers. Yeah. Now it comes to the problem: how can we check how many numbers inside? Yeah. So for example, if we are going to guess the fourth number, we have the numbers like 2, 3, 4, 6. And 8. Yeah, we have these numbers, but how can we find it easily? You know, we will not find the numbers one by one. Definitely, we're gonna find it directly. So, for example, we're gonna guess a number n equal to 4. And how can we check how many 2s and 3s? Yeah, so we're gonna use 4 divided by 2. It means we have 2 numbers. Yeah, at least we have two numbers, 2 and 4, it is okay. And 4 divided by 3, it means we have one number. Yeah, it means if this n equals to 4, I mean our guess, if our guess equal to 4, it means we have 3 numbers. That is not enough because we need at least 4 numbers. Maybe we're gonna guess a bigger number, maybe 6. So if we guess a number of 6, yeah, right. Let's just check this number 6 because this is gonna be the interesting part of the problem. Yeah, before I explain what kind of method we can use to check such kind of a problem. Yeah, so let's just guess if the number is 6. So if the number is 6, 6 divided by 2, how many numbers? It's going to be 3. We have 3 numbers that is divisible by 2. It is 2, 4, 6. And 6 divided by 3, how many numbers? We have 2 numbers. It is 3 and 6. But as you can see that we have the duplicate 6. Yeah, so this means 3 plus 2 should minus 1. It means 4 numbers. And what we require is only 4 numbers, so that is okay. But how can we do that? How can we remove the duplicate? So this is the mathematical skills we should know from high school. So this is called set theory. So let me just make a drawing. So for the set theory, if we have a set, so this is a set A and this is a set B. And this is kind of situation, it is okay because there's no common elements. Yeah, but what if there is common elements? What are we gonna do? So this is A, and this is B, and inside, for example, that number 6 is the common elements. But how can we do that? So normally we can do it like that. So we're gonna use the set theory. So for A, I don't know how we're gonna call that. A union B. Yeah. So for A union B should equal to A and let me make it right. The formula should be A plus B minus A add B. So this is just the formula. Yeah, basically for this problem, we just need to use this formula. For example, our number is 6. We're gonna guess this number 6. So how many numbers? It's gonna be divisible by 2. It's gonna be 2, 4, 6. And divisible by 3. It's gonna be 3 and 6. And this is the common elements. So if we use A plus B, 3 plus 2 minus 1, because we have one common element, it's going to be 4. This is our result. Yeah. So if we know about this kind of drawing and this kind of formula, basically we can solve the problem. Yeah. Now let's just try to use a boundary search to solve the problem. So I'm going to prepare LR and a result for the boundary search. So I'm going to start from 2. And for the R, for simplicity, currently I'm going to use 4 times 10 to the power of 4. And times another 10 to the power of 9. Yeah. Now I'm gonna use a boundary search. So let me just finish the boundary search part. So yeah, I'm gonna check the mid number, and if this is okay, I will define this check function later. So my result gonna be M, and it's gonna be, we're gonna guess a smaller number. Otherwise, we're gonna guess a bigger number. Finally, we're gonna return the result. Now, we just need to finish this check function, and inside, I'm gonna give a threshold. Yeah. Now, I want to prepare a counter. I want to check how many count. So if finally my count is more than and equal to n, so this is gonna be true, I'm gonna guess a smaller number. Otherwise, if it is false, I'm gonna guess a bigger number. That is why L equal to n plus 1. So my count will be starting from 0. And how can I count? And this is also easy. So count should plus equal to this is threshold divided by A, and count plus equal to this is threshold divided by B. And this finally, I just needed to check this count more than and equal to n. Yeah. Let me just use another example. Maybe we're gonna guess a number 7. Yeah. So for 7 is bigger than 6. Yeah. So we can analyze it as 6. It is okay because for this 7 divided by 2, it's gonna be 3. We have 3 numbers. It is a 2, 4, 6. It is okay. And 7 divided by 3, we have two numbers, 3 and 6. It is also okay. Yeah. So even this number 7 is not modular 2 or 3, but it is okay for us to guess because 7 is bigger than 6. If 7 is bigger than 6, 6 have 5 elements. So definitely, if this number is 7, I will have 5 elements, because if I minus 1, it is 6, definitely I still have 5 elements. So this is why. Even it is not divisible, even it is not divisible totally, it is okay. We just need to use this threshold divided by A and divided by B. Yeah. As you can see that I forget to minus the common elements. So the code should minus the threshold minus the common elements. So how to calculate the common elements? You can use GCD or you can use LCM. LCM is the longest common multiplier with A and B. So we can use LCM. So divided by this LCM. Yeah. So this is the entire code. Now let me just run it. What is wrong? Let me make a parenthesis because in Python there's no preference. We have to use the parentheses to make this one gonna calculate first and this one gonna calculate first, and then we're gonna calculate the multiplication between them. Yeah, I forgot to prepare the result. Result gonna be 2. I think even I don't use the parentheses, it should be okay. And the double multiplier, the power sign should always be calculated first. Yeah, as you can see, it is okay. Now let me submit it to check if it can pass. Yeah, because this one, I forget to use the modular, because according to the question, we need to use the modular. Let me just prepare the modular. It's going to be 10 to the power of 9 plus 7. Now, let me submit it to check. Yeah, I forgot to modular the m. Yeah, the mod. Now I think it should be okay. Yeah, now let's analyze the time complexity. I think the speed okay, but I'll optimize the time a little bit. But before that, let's analyze the time complexity. So this number, we're gonna call this number k. So this is a log k, and another one is this areas. So for calculating this a and b, as you can see, this is just O1, right? Because we didn't use any for loop, it is just a calculation. Even this is LCM. Maybe we're gonna call this one log n time, yeah, and this one log k time. So the time complexity gonna be log n times log k, and this log n will also be like yeah, let me think. Yeah, and 10 to the power of 9, and another log k 10 to the power of 9, or it is bigger. Let's say just maybe we're gonna use the 10 to the power of 14. Yeah, so for log 10 to the power of 14 times log 10 to the power of 14, it's gonna be a smaller number. Maybe it is just 1000. I think that is why it is so fast. Yeah. Now let's just optimize the time complexity a little bit, because basically here for the r we don't need to use such a big number. Basically this number gonna be determined by the number n times the maximum of a and b. I'm not sure. Let's just check. I think so, because if this number is 4 maximum of a and b, we're gonna use 3. Yeah, so this maximum number gonna be 3 times 4, gonna be 12. Yeah. So for this number, yeah, maybe I can use yeah, I think maximum of this number, I need to plus 1, n plus 1 times the maximum number. Let me use n plus 1. Yeah, because I'm gonna at least have a 4, and then I'm gonna have 8 and 12. That is why I'm gonna use n plus 1 times the maximum of a and b. Maybe you think this is difficult to calculate. How can I prepare such things like that? I think this depends on your experience and mathematics skills. If you are not familiar with it, maybe you can use this one directly times this one. So what is this one? This one is the maximum of a and b, right? And what about this one? This one is just 10 to the power of 9, and we're gonna just use this number n. Yeah. Now let me just run it. But for safety, I plus a 1. Maybe I don't need to do that. Yeah. As you can see, it improved the time a little bit, but basically that is okay. Definitely, I think I don't need 2 plus 1 because I have two numbers. I choose the maximum number. Definitely, it's gonna be okay. Yeah, let me try again. Yeah, as you can see, it also works. Maybe you think, why the maximum? I want to choose the minimum number. I think the minimum number is also okay. Are you sure? Yeah, because this minimum number, so for example, the minimum number gonna be 2, and this n is 1, and we're gonna choose two numbers, so it is a 2, it is okay. Maybe this n is 2, so it is 4, it is also okay. So we can also use the minimum, yeah, because the minimum is should be better than the maximum. Yeah, as you can see, it works and it's pretty fast. Yeah, I mean, for calculating this r, it doesn't matter. You just need to prepare a big number. But if you want to keep a smaller number as smaller as possible, you're gonna make mistakes. Yeah, if you didn't know about this kind of formula to calculate, basically you're gonna make mistakes. If you use the maximum, it is okay because you have a bigger boundary of this r. If you use directly the number, it is also okay because for binary search, log this number times this number gonna be a small number. That is okay. Yeah, I think basically that's for today's problem. Thank you for watching. See you next time.